So the first part of the fundamental theorem of calculus says that if you integrate a function and then take the derivative, they cancel each other out. Well, here's another form of the fundamental theorem of calculus. Take a look at the graph of this function. On the interval from 0 to 1, since it's 2 divided by something, that means that the biggest it's going to be is 2, and it's going to be positive. So 0 to 2 should do it. Okay, so on that interval we have the function is starting at a height of 2, and then it goes like this. And then find the area between the x-axis and that function. Well, one way to do it is with rectangles, also known as Riemann sums. Divide this interval into n rectangles and then find the height by substituting a value into the function. Or what we could do is integrate. Find the antiderivative on the interval from 0 to 1 of 2 over x squared plus 1 with respect to x as the variable. So with an x squared plus 1 in the denominator, then you need to recognize something like that and say, wait a second, I remember when we were doing derivatives, the derivative of the tangent of x is 1 over 1 plus x squared. Well, that's what this thing is. By the way, constants you can factor out, so multiply by 2. And it's going from 0 to 1. And then this one is tangent inverse, so it's going to be a 2 is on the outside, and then tangent inverse of x as x goes from 0 to 1. So first of all, substitute a 1 in there. So I've got 2 times the tangent inverse of 1 minus 2 times the tangent inverse of 0. So that looks like it's pi over 4 minus 0. Let's double check. Tangent inverse of 1. And then if I divide that by pi, you'll see it's a quarter of pi. So this one is 1/4 of pi minus 2 times, and then tangent inverse of 0 is 0. So it looks like it's 2 times pi over 4, or if we reduce, it's going to be pi over 2. And then no glare. And then if we graph again, so there's the function, and if you go to second calculate and have it integrate number 7, going from 0 to 1, it will find the area under the curve and say it's 1.571, which is pi over 2.